Hi everyone, I'm Kelli Li. I'm currently a PhD student at UCLA in the Department of Biostatistics working with Mark. I'll be talking about competing risk regression models and cohort studies with the R package Cohort Method. So first let's talk about some background on survival data. We are interested in time to event data. So Cox proportional hazards models are used to model time to first event data, otherwise known as survival data. So for example, if we were studying human males and we were interested in our outcome of prostate cancer development, our Cox model would model time until development of prostate cancer. So these types of models run into problems when our event of interest is censored. This means that for some reason something happens such that our time to event is not observed. This is often due to loss of follow-up or study termination, but we're interested in when this happens because of a competing risk. So competing risks are alternative outcomes that preclude our event of interest. So for example, in our prior example of prostate cancer development, if a patient dies prior, we now no longer know if he will develop prostate cancer after this point in time. So in this case, death is our competing risk, and it is commonly a competing risk. So the problem with Cox models is that they presume independence in censorship. So a patient who died is handled the same way as a patient who got censored due to loss to follow-up for or study termination, which are more standard reasons for censorship. And so we're kind of losing a lot of outcome information. So fine and gray extend the Cox proportional hazards model, where they use a function analogous to the Cox model, and they measure the instantaneous hazard rate for our given outcome of interest, while also accounting for previously occurring event types. The fine and gray models extend Cox proportional hazards models such that they can be applied to competing risks data as well. So currently in our OHDSI Hades tool stack, we have a cohort method which performs which is an R package that currently performs new user comparative cohort studies in our OMOP common data model. It implements machinery built in Cyclops to fit large-scale propensity models and 3 types of outcome models, logistic for binary yes-no data, Cox for our time to event data, which is our data of interest, and Poisson for count data. So our goal in the study was to develop functionality in cohort methods such that we are able to fit fine and gray models in cohort method using the Cyclops machinery, while also including functionalities for propensity score trimming, matching, and stratifying. So previously competing risks models are limited because computational complexity for these models scales quadratically with a number of patients. But Kawaguchi, Shen, and Suchard were able to develop a fast and scalable forwards-backwards scan algorithm to linearize this computation. So this reduces computational complexity when we have larger scale competing risk data. It scales linearly instead of quadratically. So in order to help implement this such that we can make fine-grained models more accessible through cohort method, we created 2 new functions or options, one of which is the combined competing study populations function. This combines 2 different study populations, one with our outcome of interest and then one that's interested in our competing risk, and then combines them so that we can fit the fine-grained model on this population. And then when we are trying to fit models in a multiple analysis framework in cohort method, there is an option to specify the risk ID when we're creating our outcome model arguments, which specifies the concept ID of our competing risk outcome of interest, so that we can use it in our multiple analysis framework. So in our test case study design, we model the relative risk of hospitalization for heart failure, with our competing risk being acute MI for new users under ACE and thiazides in the Optum EHR. So we fit a large-scale propensity model and perform one-to-one matching, and then we fit a fine gray model on this data. So in order for the code for this is very simple. In cohort method, we create 2 different study populations with create study population the function, where our first study population is is interested in hospitalization for heart failure, and our second population is interested in acute MI. So then we use our new function combined competing study populations, where we combine these two populations, and then we are able to fit a propensity score as typical cohort method single analysis frameworks do. And then we are able to successfully fit a fine-grained model onto our matched population. So for some of our conclusions, we are essentially able to estimate the hazard ratio, in this case under the fine and gray model using cohort method. The new novel forwards backward scan algorithm linearizes computations in Cyclops. So prior R packages with fine-grained machinery such as CMP-RSK have this at a quadratic scale, and so now cohort method in our Hades tool stack is able to provide reliable fine-grained regression coefficients in new user cohort studies while fitting propensity models and accounting for and being able to use these propensity models to stratify, match, and trim at the same time. So thank you all for listening, and
Great.
I'm honored to receive this award. Thank you.